Okay, so the first question here is we have to prove that R is the midpoint of the line, JN. R is the midpoint. So what you do is with any question, two things you look for from the start is for tangents and for center of the circles. You normally look for those two things first. Because if you have a center of the circle, you know you got radius, 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 which might help you. And you know if you have the center of the circle, when you go out, okay, and it bisects a line, then it's perpendicular. Or if it's perpendicular, then it will bisect the line. So you check, where do I go out through a chord? And in this case, we have to prove that R is the center, is the midpoint of this line. So obviously we have to use the theorem. We can think of the theorem that says, if this line is perpendicular to the chord, then it bisects the chord. So we're going to try to find out how can we show that this line here is perpendicular to JB. How can we find that OR is perpendicular to JN? How can we prove that? So what you can do is, okay, how can I show any angle is 90 degrees? In general, how can I show an angle is 90 degrees? The only way to do that is to use the diameter and check if I go out. From the diameter, I go this way, which means this angle here must be 90. Okay, angles on diameter. So that's the only way to prove any angle is 90 degrees, is to look at your diameter and see where's the diameter going. It's going that way. So the first thing we can do here is we can say angle M3 is equal to 90 degrees. Reason, angles on diameter. Okay. And then we can say, okay, well, if this one is 90, okay, and another thing you check for at the start of the question is parallel lines. Did they give you any parallel lines? And they did. They said this line, you see that arrows, this line is parallel to this line. So because these two lines are parallel, you know you can use corresponding, co-interior, or alternating, one of those three. So when you see parallel lines, you think of those three, corresponding, co-interior, alternating. Can I use any of that? Because that's most of the time why they tell you the lines are parallel. Okay? So in this case, you can say, well, okay, this one is 90, which means this one must be 90. Because they're corresponding angles. So I can say there, okay, I can say R4 is equal to 90. Now we can say therefore R4 is equal to 90. And our reason, corresponding angles. Okay, because MK is parallel to RO or OR. Okay. So we showed that this angle is 90, angles on diameter. Then we showed this one is 90 because it's corresponding angles. And then we can say therefore MR is equal to RJ. Therefore MR is equal to RJ. And our reason, because OR is perpendicular to MJ, and therefore R is the midpoint. R is the midpoint. Okay, so that was the first question. So R is the midpoint. That was question 1. Okay, now the next one. Alright, so now the second question is prove that M1 is equal to M2. We must look at this one and show that it's equal to this one. So you can use different colors. Okay, it helps to use different colors. Let's say we make them red. Okay, this angle, prove that it's equal to this angle. You can start by saying, okay, now we look at the tangent. Okay, the tangent, okay, has a chord over here. Okay, remember the tangent chord theorem? From the tangent, we have a chord. So we can say this angle, if we just draw it like this way, and then this way, and this angle, and then the chord it makes is over here. Okay, must be equal to this one. Okay, so we can say that in the beginning already. We can say M1 is equal to J1. Let's just start with that. Let's start by saying M1 is equal to J1. Okay. reason, tangent NM and chord MP. Chord MP. Okay, so you agree, we can say that. But now we have to prove that M1 is equal to M2. So now we must prove that J1 is equal to M2. If we can say M1 is equal to J, and we can say that M2 is equal to J, then we can obviously say that they're equal to each other. So now we must ask ourselves, how can we show that M2 is equal to J1? And then you must think of what you already have. Why? Because most of the time with Euclidean geometry, what you did in the previous question will help you with the next one. Many times it's like that. So you must ask yourself, what have I done so far? I've already shown that this side here is equal to this side. And I've shown that this is 90 degrees, which means I can say if this one is 90, that one must be 90. The vertically opposite, and this one must be 90. Obviously, all of them will be 90. If one of them are 90, then all of them are 90. So now it's like, okay, well, it's going to be very easy to prove these two triangles are congruent. Okay, it's going to be very easy because I already have the 90s. And many times, not many, but sometimes with Euclidean geometry, part of what you're going to have to do is still use congruency. Okay, so you must still know how to do it. So we can say angle, side and side, because this is a common line. So we can say, okay, right, in triangle JPR and triangle MPR, first of all, we can say that R1 is equal to R2. They're both equal to 90. And your reason, you can say straight line, okay, because obviously it's a straight line there and a straight line there. Secondly, we can say that RP is a common line, and then thirdly, the third reason is JR is equal to MR. Okay, that was proven. Therefore, triangle JER is congruent to triangle MPR, side, angle, side. Okay, so the fact that they are congruent means we can then say therefore, because they're congruent, we can say therefore J1 is equal to M2. Therefore, J1 is equal to M2. Now, reason congruency, and therefore we can say that M1 is equal to M2. So M1 is equal to J, M2 is equal to J1, and therefore M1 is equal to M2. Okay, so it was quite a long proof. It should count maybe like 5 marks. So that was. Now we have to prove that JOMN is a cyclic quadrilateral. Okay? So remember, for proving something is a cyclic quadrilateral, there are 3 options. Either you must try to look at from one place, where do I go? Like from JN I go this way, and I go this way. So one option is to try to prove that this angle here is equal to this angle. That's an option. If I can prove that, then it has to be a cyclic quadrilateral. Another option is to look at it from this side and to say if from here I go to N, okay, and from here I go to, let's see, we go that way and we go this way to J2. Okay, that's one option. Another option is to use the exterior angle. If you look at the cyclic quadrilateral, there, okay, it looks like exterior angle is not going to work for this one. And the other one is supplementary angles. The opposite angles are supplementary. We're not going to have that because we didn't connect this line and this line. So the only option for this one, because they didn't put in this line and this line to show the cyclic quadrilateral, all we have is it goes out there, it goes out here, is to use that one. That MO sub 10 equal angles. Okay, so we're going to try to prove that n is equal to j2. Okay, so you're going to think now, how can I show that this angle n? So let's look at n. What is n equal to? Also, it's equal to, if you think about it, there's the parallel line. Look at the parallel lines. And this is a parallel line that goes this way and this way. So if you zoom out a bit, just zoom out a bit and look at the parallel lines, then this angle should be equal to, from the parallel line, equal to this angle. Okay, that one should be equal to that one, because again, it's corresponding angles. So we can start by saying M4 is equal to N. M4 is equal to N. Okay, and our reason, corresponding angles. Okay, because MO is parallel to MK. Okay, but then we can also say that M4 is equal to J2. M4 is equal to J2. Okay, because it's the chord, it's the tangent, MT, and it's the chord, tangent MT, chord MK. And then we can say therefore N is equal to J2. N is equal to J2. So we can say therefore JNMO is a cyclic quadrilateral. Reason, MO subtends equal angles. Okay, MO subtends equal angles. So therefore there has to be a cyclic quadrilateral. Okay.